Okay, we're going to do our last parent function. So this is our last parent function. It is graphing exponential functions. Okay, so starting out, we're going to look at what is an exponential function. This is something that we haven't really talked about. I think you may have touched on it in Algebra 1 just a little bit. Okay, but a good way to think about an exponential function is actually looking at a zombie apocalypse. So, we're going to talk about The Walking Dead in Penny High School. The zombie virus has infected a student in Mr. Schieber's Algebra 2 class. This student will infect 2 students on the first day. Then those 2 students, along with the original one, will infect 2 students on the next day, and so on. That pattern will continue. So what I want you guys to do real quick is go ahead and pause this video and answer those 2 questions down below for how long you think this will take. Okay, after you got your guesses down, go ahead and let's go over to the next slide here, and we're going to look at this example. So, like we said, we're starting out. There's a Walking Dead in Penny High School. So we're going to start out. You got patient 0. Okay? And patient 0 is going to go and infect 2 other people. Okay? And that happens on the first day. So that means over here on my chart, on day 1, there are 1, 2, 3 zombies that we have. Okay, so on day 1, there are 3 zombies. On day 2, each of these guys are now going to infect 2 more people. Okay, so on day 2, if we count up, we've got 6 new zombies plus our 3 original ones. So that's going to give us 9 zombies that we have on day 2. Day 3 comes along. Each of these guys are going to infect 2 more people. So of those 9, we had 9 originally. Now we're adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 9 and 18 is going to give me 27. Okay, so on day 3, we have 27 zombies. Then, each of these are going to infect 2 more. And what I hope you guys are noticing is that these numbers are starting to get really big really fast. And some of you guys may be noticing a pattern even as we're going and may be able to anticipate on day 4, on day 5, on day 6, and on day 7 how many that we would actually have. Okay? It's an exponential function, which turns out actually means that these numbers in my x column here are going to be going up in the exponent. So I can look at this column here, 3 to the first power. This column here, 3 to the second power. This column here, 3 to the third power. 3 to the fourth power gives me 81. Then if I need to look at 3 to the 5th power, that's going to give me 243. So in 5 days, we're going to have 243 people that are zombies. And it started out with 1 kid in Mr. Schieber's room. Okay? So then if we keep climbing here, 3 to the 6th power, that's going to give me 729. 3 to the 7th power is going to give me 2,187. Okay, which 2,187 is 300 more than our town population. So if you guys are looking at a zombie apocalypse here, it's not going to take very long to make those numbers be really big. Okay, so far we've talked about our exponential functions, and what I want you guys to know about your exponential functions is that they get really big really quickly. That's the main thing that I want you guys to know. Okay, so now we're going to take this table here, and now let's actually graph this table and see what it looks like. Okay, so starting out, I've got my x values down below, my y values over here on the left. So on day 1, we had 3 people that were infected. So we can put a mark down here. Day 1, we had 3 people. Day 2, we had 9 people. It's still pretty low down there. Day 3, we had 27. So 27 is going to be sitting right above this 25 here. Day 4, we had 81. So 81, halfway between 175, probably closer to 75. Put our day right there. Day 5, we had 243. So day 5 is going to jump way up here to right underneath my 250. And then on day 6, I can't remember what I had, 729 on day 6, that's completely off our graph. So if I graph this function, I draw it out here, it starts out slow, but it gets really big really quickly. Okay? And that's the same general shape that we're going to have for our exponential functions. So let's go ahead and move on, and let's actually talk about what our parent function is now that we know what our exponential functions kind of look like, some general rules for it. Our parent function is going to be y equals b to the x power. Okay? B is called your base here. Okay? And that's the most important part. This b is called your base. Okay? Your base must be greater than 0, and your b cannot equal 1. So it's got to be a number that's between 0 and 1, like a proper fraction, or it's got to be a number that's greater than 1. Okay? It can't equal 1 because 1 to any power is just going to stay as 1, so it'd just be constant, a straight line. Okay? But so y equals b to the x is our parent function. That b again stands for base. So this parent function is going to be unique because the parent function is going to constantly be changing depending on what the base is. Okay, so let's look at a few parent functions and see how they look. We're going to start out with y equals 3 to the x power. So I've got y equals 3 to the x power. And as we've done with all of our other ones, we're going to start out with a table. Okay, so I've got -2, I've got -1, I've got 0, I've got 1, and I've got 2 that I'm going to plug in for this function here. So starting out, I've got y equals 3 to the x. Let's start with an easy one. Let's plug in a number 1 for our x. So that's y equals 3 to the first power, which y equals 3 to the first power would just give me a 3. So I can plug in a 3 to this spot here. Next, let's look at y to the second power. Okay, well, y to the second power is just going to give me 9. So I can plug a 9 in there with my 2. Okay, next, we'll look at 0. Okay, there's a special rule for 0. Anything to the 0 power equals 1, is what I hope you were saying. Then we're going to move to our negatives. Okay, so we're at 3 to the negative first power. Now, when we're dealing with negative exponents, remember that means we need to change where they're at in the fraction. So 3 to the negative first power, that's still a 3 to the negative first power over 1. That negative exponent tells me that I need to move that to the bottom, which means that I'm going to have a 3. Oh, I'm sorry. That was a mistake. Which means I'm going to have a 1 on top now over a 3 to the first power, which 1 over 3 to the first power is 1/3. So that means in my -1 spot up here, in my -1 spot, I'm going to have 1/3. Okay? Now let's switch. Let's look at 3 to the -2 power. Okay, same rules apply. It's a -2, so that's going to have to drop it down low there, which is going to give me a 1 over 3 squared, which a 3 squared we know is 9, so that's going to give me 1/9. So I'm going to have 1/9 down here. Okay, so I've got my 5 points now, and now that I have my 5 points, I'm ready to graph them. Okay, so I've got my graph over here. I'm going to graph -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 3, 9. Okay, and after I graph those, I'm going to connect those points. And we saw on that last one that we did, it's a smooth curve that connects all of those points there. Okay, now after you get those points connected, I want you guys to take a look at your graph and notice on the left side that your graph kind of flattens out. Okay, And that is because this parent function here has an asymptote. Okay, and it only has one. So this exponential function that we're working on, it does have an asymptote with it as well. It is a horizontal asymptote. Okay, and you guys can tell on the left side, this function on the left side starts getting close to it, but it's never going to cross that axis there. Okay, and that's because no matter what I make these, no matter how big that negative number is, it's always going to just turn into a fraction. So it's never actually going to get below 0. Okay, so there's one parent function that we could have. Okay, well, what if, we've got our domain. Let's just skip the domain for right now. Skip the domain and range. Okay, let's look at our other parent function here. Okay, this time I've got y equals 1/2 x. I've got y equals 1/2 x. Okay, same thing. I'm going to create my table. Okay, I've got -2, -1, 0, 1, and 2. Okay, so this is going to be a little bit different. Y equals 1/2 to the first power. Well, anything to the first power is just itself, so you're going to have 1/2. Y equals 1/2 squared. Okay, now when I'm squaring a fraction here, that squared has to go to everything. So this is going to give me 1 squared and 2 squared, which is just 1/4. So my squared is going to give me 1/4. Okay, now let's say we switch it. Let's say I put 1/2 to the 0 power. Well, anything to the 0 power is 1. Okay. If I put it to the negative first power, remember we talked about how this goes to both of them? Which means I'm going to have a 1 to the negative first and a 2 to the negative first. And negative exponents means you need to switch their spots. So I've got 2 to the first over 1 to the first, which is just 2 over 1, which is 2. So I've got a 2 with my -1 there. And then similarly, if I had a -2 there, that would mean a -2, which would cause them to flip, and it ends up making it a 4. Okay? Now when we graph this parent function, you're going to see it looks a little bit different. I've got my -2, 4. I've got my -1, 2, 0, 1, 1, 1/2, 2, 1/4. I'm going to draw my horizontal asymptote and then draw my smooth curve. Now it still has the same general shape as the other. Okay? However, this function here is going the opposite direction. Okay? And we will find when you guys work through these, if you see this one here, this is a fraction. And more specifically, it's a proper fraction. Okay? When you guys are working with proper fractions, your function's going to look like this here. Okay? So if your base is a proper fraction, it's going to look like that to your right. And then when we have a whole number, like we did on our last one, y equals 3 to the x, you're going to find that your function is opening up the opposite way. Okay? So if I have y equals 3 to the x, where 3 is a whole number, it's going to open to the right. If I have y equals a proper fraction to the x power, it's going to open up over here to the left. Okay? They're still both the same thing. It's just going to depend on what type your base is. So real quick then, in summary, okay, when you guys graph your parent function, I'm only going to make you graph 3 points. Okay, I'm going to make you graph 0, 1, and -1. The reason is, it's pretty easy to figure these out. It's just a memorization thing. 0 is always paired with 1. And the reason is, I've got y equals b to the x. Anything to the 0 power is always 1. Now 1 is always paired with your base. Okay? Anything to the first power is always just whatever that number is. -1 is going to be your reciprocal of your base, because a negative exponent causes it to flip. Okay? Next video, we're going to continue talking about this.